Hello, I am Ninad Kulkarni and welcome to my doubt solving session. The question says if A is equal to a 2 by 2 matrix 3, 1, minus 1 and 2, then show that A square minus 5A plus 7I is equal to 0. Hence find A inverse. So there are two questions in the same question. That means we have to first show that A square minus 5A plus 7I is equal to 0. After that we have to find A inverse. So we will first note down the matrix A. 3, 1, minus 1 and 2. And we have to show that A square minus 5A plus 7I. I means unit matrix is equal to 0. Now first component is A square. There is a first component is A square. Okay. Now for finding A square you have to multiply A, matrix A with matrix A itself. It's just like the numbers. If you find the numbers square, then you have to multiply the number by the number itself. Similar case applies to the matrix also. So you have to multiply A with A. That means 3, 1, minus 1 and 2 into 3, 1, minus 1, 2. Now, this is a 2 by 2 matrix and this is also a 2 by 2 matrix. There are 2 rows and 2 columns. Okay. Now, what happens is if the number of columns of the first matrix, and number of rows of second matrix, and number of rows of second matrix are same, then the matrix will become this by this, first and last. Okay, so that means it will be a 2 by 2 matrix. Now we will do the multiplication. So first element will be first row of first matrix multiplied by first column of second matrix. First row of first matrix multiplied by first column of second matrix. So first element is 3 into 3. So 3 into 3 is 9. 1 into minus 1. 1 into minus 1 is minus 1. 1 into minus 1 is minus 1. So this is the first thing. For the second element, you have to multiply first row into second column. First row of first matrix into second column of second matrix. That means 3 into 1. That is 3. Plus 1 into 2. 1 into 2 is plus 2. Understand this? Third element, minus 1. That is second row of first matrix into first column of second matrix. Second row of first matrix into first column of second matrix. That means minus 1 into 3 is minus 3. 2 into minus 1 is minus 2. And for the last element, second row of first matrix into second column of second matrix. Second row of first matrix into second column of second matrix. That means minus 1 into 1. Minus 1 into 1 is minus 1. 2 into 2. 2 into 2 is plus 4. So this is the multiplication. 9 minus 1 is 8. 3 plus 2 is 5. Minus 3 minus 2 is minus 5. Minus 1 plus 4 is 3. Okay. Next, So this was about a square. Next is minus 5a. That means you have to find 5a. You have to find 5a. So 5a is equal to 5 into a. A is 3, 1, minus 1 and 2 is equal to 5 into 3 is 15. 5 into 1 is 5. 5 into minus 1 is minus 5. And 5 into 2 is 10. Okay. Next, 7i. Next term is 7i. So 7 into I means unity matrix, is equal to 7 into unit matrix is written as 1, 0, 0, 1. So it comes as 7, 0, 0, 7. Okay. So these three terms we have found out. Now you have to so these are the three terms. A square 8, 5, minus 5, 3, 5a 15, 5, minus 5, 10 and 7i is 7, 0, 0, 7. Now you have to add a square minus 5a plus 7i is equal to a square is 8, 5, minus 5, 3, okay, minus 5a. So you have to subtract this matrix 15, 5, 5, minus 5 and 10. You have to subtract this matrix plus 7i. Okay, so plus 7i, 7, 0, 0, 7. Okay, so this is the addition is equal to, so you have to add, all these are 2 by 2 matrix, all these are 2 by 2 matrices, so the resultant of addition and subtraction is same, 2 by 2. Okay, so we have to add the first elements of each matrix. 8 minus 15 plus 7. Okay, plus 7. Now second element 5 minus 5 plus 0. Next element, this second row, first element minus 5 minus of minus 5, that is plus 5 plus 0. And last element 3, this element 3 minus 10 plus 7. So you can see here 8 plus 7 is 15, minus 15 is 0, 5 minus 5 is 0, minus 5 plus 5 is 0 and 3 plus 7 is 10, 10 minus 10 is 0. So you can see we have proved that a square minus 5a plus 7i is a null matrix, Now second step is you have to find A inverse. So we know that for finding A inverse you have to find first determinant of A. That is 3, determinant of 3, 1, minus 1, 2. Okay, that is 3, you have to multiply diagonally. 3 into 2 minus 1 into minus 1. Okay, 3 into 2 is 6 minus minus 1. 6 of minus 1 into minus 1 is minus 1 is equal to 6 plus 1 is 7. 6 plus 1 is 7. Okay, now we know that A inverse is equal to 1 upon determinant A into adjoint of A, So for a 2 by 2 matrix, the adjoint of A can be found in a simple way. What you have to do is, you have to interchange the places of the first diagonal element. That means 3 and 2. You have to interchange their places. So 2 will come here and 3 will come here. Okay. So I will write 2 and 3. Okay. 1 and minus 1. You have to keep them at same places. But change their signs. So 1 will become minus 1 and minus 1 will become plus 1. Okay, is equal to 1 upon determinant of A is 7. 2 minus 1, 1, 3. Okay. So you can write A inverse is equal to 2 upon 7 minus 1 upon 7, 1 upon 7 and 3 upon 7. So this is your solution. So we have proved A square minus 5A plus 7I is equal to 0. And also we have found A inverse as 2 upon 7, minus 1 upon 7, 1 upon 7 and 3 upon 7. Hope this solves your doubt and answers the question. Thank you very much.